Cool. You hear me, right? Okay. So in 25 minutes, we are going to have lunch. So hopefully you can stay with me. So the topics of today is real-time analytics platforms. Uh, Actually, we interact with real-time analytics platform more often than we think. I could say almost on daily basis. The application range from well super intrusive behavior like user tracking behavior on social medias or user analysis behavior on e-commerce platform like Amazon's or and so on and so on. Or it may come out to be something more constructive, like analyzing the health status of your application in real times. So all of them relies on the core fundamental, which is a real-time data analytic platform. Um, so as I said, the applications is quite diverse, hence the source of the data is also diverse. Uh, the real-time characteristic of the analytics actually becomes revolutionary in the modern world. It gives companies, gives teams, it gives the stakeholder the ability to actually dive into the user behavior and takes action in real times. Imagine you I think you have noticed that you do some things on, you search something on Google and instantly, like 30 seconds later, you see your YouTube recommendation change. It adaptive. So all of that thanks to the real-time feature of the analytics platforms. So on the highest level, we can characterize, we can put like a big components on top of the platform. Of course, it's a complex thing which involve a lot of components, but let's try to put it into four categories. The first one is the event sources. The event sources are the producers of your data. Depending on the application, it can be, let's say, the web browser, which actually tracks your mouse movements, or it can be your mobile phone application, which tracks your data, or in some cases, it can be the logs of your web app deployed on cloud platform, which generate the logs, hence the metrics. Then, because in most of the time, we're working with data at scale. So synchronous communication has never been an option for those platforms. Hence, we need a separate transportation layer, the transportation component. The job of the transportation component is to bring the data from the source and forward it to the consumer side. The consumer side now can be the aggregation layer, which is the brains of the system, which collects the raw data and calculate the metrics. It can be simple as average, count, sum, medians, or it can be multi-layer complex metric built on top of each other. But the aggregation layer is the brains of the system. Then we have another component which is critical in my opinion, but sometimes overlooked. It's the storage layer. In most of the cases, we want to store not only the result of the aggregation, but also the raw data itself. So we are going to look into each of these components in detail right afterward. The event source and the transportation layer, usually they are coupled together. As I said, the event source can be anything. It can be the web browser, the mobile phone applications, or whatever source of data which are interesting enough for us to capture. Interesting for the company, sometimes not interesting for us. Me, I don't want like big tech tracking me, but that's life. So my phone is the source of the data for them. Then we have the transportation layer, as I explained a little bit earlier. A few characteristics of the transportation layer is that, first of all, it needs to handle data at scale. It needs to be fault tolerant. It needs to be able to sustain disaster. It needs to be able to recover. It needs to be able to recover by itself in case of disaster. Due to those characteristics, usually we go with message queue. Uh, a very popular framework is Apache Kafka. The key feature which makes Kafka popular is that it has the capacity to retain the message even after the consumption. That's why it's super popular. However, not all the time we need that full-fledged capacity. In some case, let's say in IoT application, for example, in some time we are okay in accepting, well, we may lose a big chunk of data. We can just catch up with the latest status, and it's okay to design system like that. In such cases, Redis or RabbitMQs, it's also popular. It's easier to deploy, easier to maintain. So that's the transportation layer. The next part we are going to talk about is the storage layer. Usually, people, when we think about storage, we may want to store only the result of the calculation of the aggregation. However, the critical part of the storage layer is actually to store the raw data. Why we are interested in storing the raw data? Because first of all, raw data gives us the flexibility to look back into the history. Consider it as a time machine which allows us to travel back to any point in time. I would love to have a time machine, by the way. I can buy lotteries and just don't work anymore. That would be nice. So to store the raw data, it gives the time machines, and another thing is that we can do reconciliation and recovery really quickly and with confidence, because as with the improvement in technology and architecture, real-time has become so reliable, but nothing actually can beat the reliability of a good batch job running on a classical old database. So that's why we want to store raw data as well. Now, usually we have the component to ingest all of the data coming out of the transportation layer directly into the raw storage layer. Hence, the key requirement for the raw storage layer is that it needs to support high volumetry of write inputs, because as the data comes in, it needs to be able to sync the data into the storage without creating any bottleneck for the system. So to support high write query, needless to say, it needs to be highly available and it needs to be fault tolerant, because this is the last line of defense we are going to have in case of system failure. So it needs to be fault tolerant. However, we do not want to access the raw storage layer every seconds, every minute. Usually people access it only when there is an incident or they want to perform complex query and so on and so on. So if we want to trade it off, we can say we can accept low latency retrieval query. So a read query may take longer time than another traditional database, but we are okay with that. And it can be low consistent, which means once the data is ingested, it doesn't have to be made available right away. It can be made available, I don't know, like a few seconds later, a few minutes later. We are okay with that. However, the key feature is to support high write inputs and extremely reliable. Due to those requirements, usually people go with, if they are on the cloud, they go with Amazon S3 or Azure Blob Storage or equivalents on Google or any other cloud storage they should provide. Or if they go with self-host platform, usually it's RTFS, which satisfy all of those key requirements. We have to say that with the new improvements in Amazon S3, for example, it has become really consistent, and the the latency for retrieval query has been improved significantly. So this trade-off here may no longer make sense now already, or maybe in the very near future. Before talking about the aggregation layer, we need to talk about what aggregation on real-time stream means. When we work with real-time data, we are working with unbound data. So there is no starting point, no ending point, there is no boundary. It just keeps coming like that. Hence, in order to make it work, the aggregation layer need to rely on the window operations. The window operation is the mechanism which allow the aggregation layer to cut down the event stream into smaller pieces of information so that it can perform aggregation on. Because let's say if you want to calculate a summary or an average, you need the starting point and you need the ending point. It can't be boundless. Hence, window operations. The two popular window operations we are usually see is the overlapping window and non-overlapping window. As the name said it all, overlapping window, we cut the data into overlapping pieces of information. Non-overlapping, it doesn't overlap at all. It's obvious. However, the third category is the session-based window, which is more interesting. So for web app or web platforms, it actually groups the events produced by the same user to the same window so that we can easily perform calculation like how many clicks a specific user has performed over the spans of 1 minute or half a minute, for example. Now we know enough about the key aspect of the aggregation operations. What are the key features of what are the key requirements that an aggregation layer needs to satisfy? First of all, the incoming data is messy, especially in real time. So it needs to be able to handle data deduplications. We may deal with multiple events repeated multiple times, or we may even need to deal with missing events. So as the quality of the incoming real-world data is questionable, it needs to be able to handle deduplication really well. Then it needs to be able to provide exactly once processing, because processing the same event twice, 3 times, or multiple times will falsify the aggregated metrics, and that's not what we want. Then it needs to provide a key functionality which called checkpointings. What is checkpointing? Checkpointing is a capacity which allows the system at any moment in time to know exactly where it has been, where it was in case of crash of disaster recovery, so that when it get restarted, maybe after 30 seconds, after 1 minute, after 1 hour, it should be able to pick up where it left. This is the key, you can say the key guardrail for any aggregation framework, any aggregation system. And with that checkpointing in mind, recovery becomes way easier. Due to those very strict category of requirements, it's not recommended, or no one's actually, well, some may do, but most people do not build aggregation service from scratch. There are teams who have resources, who have specific requirements, who build everything from scratch, but usually people go with major frameworks like Apache Spark Streamings, Apache Flink, or Apache Binodes. Each of these frameworks approach the same problems differently. For example, Apache Spark Streamings as a batch processing framework, originally it's cut down the data in smaller batches. So it's a mini batches, and it's process the real-time data as a batch. It's just like imagine a batch that's re-execute very frequently in the span of a few seconds. Apache Flink, which is a native real-time aggregation engine, or Pinot. Well, I put it there, but I have never worked with that, and I don't know why I put Pinot there. I know that it works, but I just don't know about it, so don't ask. Yeah, but in any way, each of the frameworks has very specific requirements and require very specific knowledge in terms of deployments, operation, maintenance, and even working with it. Like a very competent user in Spark may take some time to adjust him or herself to work with Flink. So that's the complexity of the aggregation layer. Now, let's take a look into the output of the aggregation layer. Usually, in some cases, we don't want to store the output of the aggregation layer. We can just export the aggregation layer as it is. Why so? Because people can just interact with the aggregation layer directly. The computation will be done in real time as well. It's computationally expensive, but it's doable, it's workable at some scale. However, ideally, people add an extra layer of storage as an output so that we can store the output of the aggregation layer, and the output can be exposed, reconfigured, and reused. The key requirements for the storage of the aggregated data pretty much the same as the storage of the raw data. It needs to support high write input. It needs to be available. It needs to be fault tolerance. However, this time it needs to support low latency read query because people are going to query it very frequently. And in terms of API, it is subject to be abused by the user. So it needs to support really low latency query as well. However, it doesn't have to be consistent because in most of the cases, we are okay with not having the listed result right away after the query. So when the result coming out and there is a query coming in like few seconds later, it is okay to give the user the previous version of the result. It's okay to let user wait for a cooldown time until the results coming in. So we don't have to be that high consistent in such aspects either. As you can see, putting in place all of those components together is complex. It has a lot of moving components. Each component requires specific skill sets in operating and in maintaining all of them. So there are a few patterns that I have seen teams adopt really often to make things ways easier. The first pattern, I use that, my team use that, we love it, so that we drop the aggregation layer altogether. So no aggregation layer, no spec, no fling, no pinode, no whatsoever. We directly rely on databases to handle the job. Why so? Because with recent development in database technology, many databases, especially NoSQL databases, they can provide the aggregation query very efficiently. Of course, if you want to do really intensive query aggregation on top of aggregation, maybe you need maybe you need to take a look into the configurations, or maybe you need to consider the extra overhead on top of the database. But most of the times, for the basics aggregation, it's just work out of the box. You can take Elasticsearch, MongoDB, or notably ClickHouse, for example. They all provide efficient analytics query capacity out of the box. A second pattern I see very often as well is on we still rely on the, let's say, Elasticsearch, MongoDB, or ClickHouse rely on the database to perform the aggregations. However, we add the raw storage layer on top of that because with the raw storage layer, we have the capacity to do really in-depth analysis. Let's take an example of Amazon S3, for example. When we store the data in Amazon S3, Amazon provide Amazon Athena, which allows us to perform analytical query on top of S3 in a very cost-effective manner. So we don't have to worry about anything else. We just spawn up the system and our data science teams can just use that. We have to pay Amazon, of course, but nothing free in this world, so we accept that. So yeah. And another example is if you use HDFS, for example, you have Hive. Well, recently people start to move on to cloud, but HDFS is still popular, and if you put Hive on top of that, it works to some extent, and it simplified a lot of the technical stack so that the team can focus on delivering the business value. Reconciliation and data recovery. Well, in any system, things happen. It may crash, it may be inconsistent, and so on and so on. So thanks to the raw storage layer, we can put in place a mechanism called reconciliation, which from time to time recalculate the same metrics, but this time based on the full picture of the data, on the raw data itself. And it can reconcile the result with the end streams system, real-time system, so that we have a better like a better visions of what goes wrong and so on and so on. Where to go from here? So with the arrival of all of the LLMs, the chatbot, and so on, if you notice, behind each and every excellent chatbot lies a search engines. Because have you tried using, let's say, very competent model locally? The answer quality is quite questionable as well. So to make the difference, it's the job of the search engine to provide the data in the context or provide data in the retrieval augmented pipeline. So with all of those systems in place, we can actually exploit it to expose all of the indexes data to serve the search engines. That could be another topic, but with the base, we can make it happen. So yeah, that would end the talk for today. That would be it. If you have question, I think.
Let's do questions, guys. One second, just hold your question. So what's the purpose of this transportation layer? I mean, what are you transporting and where?
Yes, so the transportation layer transport the data from the source to the aggregation layer, because we can't usually just expose directly the aggregation layer to the source, because we need to, you can say, we need to build data pipeline here, for example, to ingest the data in the raw storage in the aggregations. So it's kind of like bifurcations to redirect data into different directions.
So my question is more in detail. So you mentioned like an event log, two methods, so window and overlapping window.
Yep.
Could you like explain the benefits of each?
Yeah, it could be very short. So imagine I want to use non-overlapping windows. I have 3 events, so I divide it into 2 windows. The first one will take event 1 and 2, and the second one will take event 3, so that my metrics will be separated. So I'm making sure that the output metric is calculated separately. However, in the overlapping window, I can have the same window, like the window 1 and the window 2 can have the same events, which is event 2, for example. The purpose of that is that sometimes in statistical analysis, the output of the aggregation will be a little bit smoother. It's kind of like smoothing functions to smooth the outputs. And for the third type of window, the session one, it group all of the events of the same window sessions in the same scope, in the same sets of events. So it's easier to perform analysis per users.
Any more questions? Yeah, coming.
So about the transportation layer. So
Yes.
is my understanding correct that there we store the data in the GDFS or S3 in these formats? Or is just like, can you elaborate a little bit?
Yeah, actually the transportation layer just transport data. It's like the transporter. It doesn't store anything. It brings the data from the event source to wherever we want to. It is actually in the raw storage layer where we actually store the events. The transportation layer is like the postal service. It delivers the package but doesn't store it anywhere. Well, it's temporarily stored, but after the delivery to the destination, it's just like ends of the responsibility.
Okay, can we then imagine it as an application, so which is particularly doing the streaming job, and then basically it's application that's doing later aggregations, or later than storing the data and materializing it in a row?
Yeah, it's actually, there is always an application like that to process the data, and because, well, the data cannot just fly from transportation layer to the raw storage layer. Usually we have a very lightweight application to consume the data and perform the right inserts and so on and so on, but it's extremely lightweight, and the job is just like to get data there and store it wherever it is, wherever we want it to be.
Okay, thank you.